Another gas law problem similar to the one we just did. I'll solve this a little differently to give you different looks. Let's start with using the units to identify what we're given. Kilopascals is a unit of pressure. Celsius is a unit of temperature. And we're given a second pressure. So this is P2, and the first one is P1. So we have changing conditions of a gas. We're asked to solve for T2. What is the temperature? And we're told the volume is constant. So we can start with the ideal gas law to solve all these gas law problems, which goes PV equals nRT. And move all the constants to one side and all the variables or the things that are changing to another side. In this problem, we have pressure and temperature changing. So we can move temperature over to the other side by dividing through by T. And we can move volume, because that's constant, to the other side by dividing through by V. So we're going to get P over T is equal to NR over V. All the stuff on the right side are not changing. That's a constant. And because that's a constant, we can say that P1 over T1 is equal to any other combination of those two variables of this gas. So that's going to equal P2 over T2 is going to equal to P3 over T3, and so on. So this form is known as Gay-Lussac's law, which states that pressure is directly proportional to the temperature in the Kelvin scale. Speaking of Kelvin, let's convert all the temperatures in Celsius to Kelvin by adding 273 to it. So T1 is 300 Kelvin. And that has 3 sig figs, so maybe I should put a decimal there. And T2 is what we're solving for. We can't use Celsius because it's not an absolute scale. In other words, it has negative values. We need a scale that starts at 0, and Kelvin starts at 0. Next, let's rearrange Gay-Lussac's law to isolate for the variable we're solving for is the final temperature. I'm going to cross multiply to get rid of the fractions. So T2 times P1 is equal to T1 times P2. Now we can isolate T2 by dividing through by P1. Now we can plug in our values. T1 was 300 Kelvin. Our second pressure, 225 kilopascals, and that's going to go over the initial pressure, which is 198 kilopascals. Kilopascals are going to cancel out. Our answer should have 3 significant figures, because all the given measurements have 3 sig figs on their absolute scales. So our final temperature is 341 Kelvin. And if you want to convert that back to Celsius, you can subtract 273, which is 68 degrees. FYI, you can't have 3 sig figs in your Celsius answer, because 67.9 degrees Celsius really has 4 sig figs on the absolute scale.